Okay, I'm going to give yet another perspective, another viewpoint on this, this topic of virtual reality. Actually, Jaron and I are on the same program, same panels, so often that we should probably figure out a way to just do this in parallel and just kind of dump it. Would be kind of amusing, I think. What I'd like to do is try to explain a couple essential issues of getting this sense of presence. Again, it's something that's been around for centuries. The first is this idea of literally immersing someone in an image. We've had panoramas for over a century. Turn of the century, we started to have projected images to give a kind of panorama as shown here. Eventually, it moved into dynamic, moving, large images. This is actually a shot of a boat simulation. You would actually stand on this boat, and these huge murals would be wound past the sides of the boat where the audience was looking out on both sides. Actually, only one is shown here. We still use this kind of technology in our flight simulation areas. This is actually a 30-foot diameter dome that's in Florida, used to train helicopter pilots. The pilot sits inside the dome and is completely surrounded by computer projected imagery. The nice thing about the simulators, though, is that unlike most of the media that we're used to, it's not a passive thing. You literally can drive your viewpoint through those environments that are projected for the pilots. So the idea of large immersive environments, the idea of being able to control your viewpoint are two of the kind of salient features of virtual environments. About 5 years ago, a group of us at NASA Ames started a project that we call the Virtual Interface Environment. Now it's called the Virtual Environment Workstation project. And the idea was to try to get some sense of this multi-sensory virtual space as an interface for a number of different tasks. For our applications, what we've done over the last 5 years literally have to be anchored in NASA missions. In particular, my group has been working mostly on work for space station-related tasks. The first has to do with trying to give an operator, say an astronaut inside space station, some way of literally controlling the telerobots that are outside space station. If we can keep him from having to suit up and go outside in this hazardous environment, that would be great. So the robots are being designed to be semi-autonomous. That is, they're smart enough to do a lot of the boring maintenance and inspection tasks. In the cases where they can't figure that out, they literally have to notify the astronaut and go into what we call telepresence mode, where he's literally seeing through the eyes of the robot, using the gloves to control the remote end effectors, using 3D sound cueing to tell him where other objects are in the workspace, etc. We're working with our computational fluid dynamics engineers to try to take information that they normally look at on a two-dimensional screen and put it in our environment, this full 3D space, and let them literally fly around these vortex flows, or literally become one of the particles in the flow. And we're finding that although we haven't done very rigorous testing so far of their interaction with the environment, but it's usually hard to get them out of there. They find it very useful and very informative to their kind of applications. The longer term application will to try to make this an interactive design tool. For example, using the gloves to design an airplane wing surface, to then see the turbulence flow over the wing surface in real time, to be able to change the wing shape and see the change in turbulence. Computationally, that's obviously still very difficult and maybe a ways away, but that's something that we're just starting to work on to make it a kind of interactive tool. Other commercial applications that we've been approached about, obviously recreation is the most popular. Lots of theme park operators, designers have visited, video game manufacturers, etc. That's a pretty obvious one. What we're interested in now is trying to expand the system for use by more arts-based applications. This is an old slide of Pablo Picasso doing a kind of simulation of drawing in 3-space. We now have software where you can literally do this in the virtual environment. You can actually build shapes and objects around you. With a particular gesture, you can then scale the objects up to quite large, be inside them, or scale them down to quite small. When this stuff gets into Zippy, you know it's here. You've probably all tried the VPL version. I hope you'll try our virtual camera system. This demo may look kind of simple. It's actually a life-size replica of the lab that we work in. It's a very, very difficult thing to do. Our objective was to see if we could do that. If we could make it so that when you reached out to touch the virtual object, you would literally intersect the real object in the same room. So there you can see I don't see my real hand when I'm in there, so we developed a computer-generated model of the hand that's controlled by the data glove. Before we did that, people reported getting quite dizzy. You were kind of this disembodied viewpoint within the virtual space. Once we put the hand in there, those complaints literally went away. It seemed that having that frame of reference of yourself immersed in the space really helped. Now I'm reaching up to just touch this piece of wood hanging down from the ceiling, and again I actually feel the real object when I do that. Here's what I'm actually seeing, well, obviously minus me in the corner, and I make a particular gesture now. I think it's a three-finger point at that time, and this large menu that's about 1 meter high, floating out in space in front of me, pops up.
Flying enabled.
Now I made yet another gesture, and I triggered an object, a command on that menu that lets me now fly my viewpoint up out of the room. Now that's something that's been looked at and probably will become a product by Autodesk as a tool for architects to literally design spaces that you can walk around in before the building's actually built. Here's a entry into the virtual space, something that Mark Bolas did where that particular world only exists from that one viewpoint. As soon as you step off it, everything dissolves into these line segments. This is the fuel flow through the shuttle main engine. Again, the engineers can literally get inside there and grab the whole flow and stick their head in it if, in fact, that's helpful to do. And then we end up flying off to another database that represents a very crude model of an early space station configuration, what we call the power tower. But the idea here was more to look at information and communication aids for an EVA astronaut. The idea was to again have this idea of portable information spaces.
2 hours left.
Where he could call up schematics, say, for a satellite that he's working on, and park them in virtual space in front of him and refer to him as he's doing that repair. Currently, all he has is this thing we call a cuff checklist. It's literally a bunch of index cards glued to his wrist. So here we have almost an infinite capability to provide any kind of information he needs.
Map cube on.
This may be a little hard to read. It's actually it's a cube that's about 1 foot on a side that floats in front of him that shows where the other objects are in that workspace.
Locate.
If he reaches in and touches one of those little objects, it draws a line off to the real object in the workspace, and well, the real virtual object in this case. We get in these loops, which are kind of strange.
Viewfinder on.
Now what he's done is...
Oxygen very low. 72 minutes left.
Okay, so now he's got to get out of there. Not enough oxygen. So he calls up this viewfinder window, which in fact is a three-dimensional window hanging in the 3D space. He grabs it, he stretches it to fill his field of view completely, and it's literally a kind of wormhole, a door into yet another database. In this case, it happens to be this other project we're working on, which is a life-size mock-up of 2 Puma robot arms for some of our telerobotics interface work. Now this one is actually a virtual musical instrument. I don't know if you remember what theremins are, but this was done by Mark Bolas and Phil Stone, both musicians who are on the staff. The idea was to make a musical instrument where you could literally use hand gestures to select different voices off the synthesizer and then modulate them in different axes. You can modulate pitch in one axis, amplitude in another axis, and change the filters on the synthesizer in yet another. So again, remember this is a full 3D environment. You're surrounded by this stuff and you're kind of building this sound space. Now he's toggled it into another mode, which is a virtual drum kit. Now as he intersects those surfaces, can you turn that up a bit? Great. He can select different sounds off the synthesizer. So back to reality. Thanks.